Okay, so now we're going to be doing a circuit. Is the N-channel enhanced Mosfet as an amplifier. It's another type of a transistor. It falls under the FET, which is the field effect transistors. And then over here I've got all the components. I've got the circuit diagram here. Basically what's going to happen is that I'm going to give it a small wave at the gate, and then what's going to happen is that on the output to give me an amplified one. So basically I'm using it as an amplifier. And these are the components I've got. I'm gonna use the input here, which is actually I'm gonna get a sine wave, which is 1 volt VRMS, and then I'll be using a signal generator to generate that. And then I've got my 100 nanofarads here, that's the capacitor, and then I've got my 100K, and then I've got my 200K. These are the basing resistors, that's the R1 and R2. And then over here I've got my 470 ohm resistor, and then I've got my 150 ohm resistor. And then on the output also I'm gonna put another capacitor there, which is my 100 nanofarad. And then basically what's gonna happen theoretically, if I give it a sine wave, on the output is gonna come inverted, so meaning it will be 180 degrees out of phase as I compare it to the input, and at the same time it will be amplified. So it works the same like your op amp. If I'm taking the input to the inverting terminal, and then on the output it will come out inverted at the same time amplified. So I'll be connecting the circuit. I'll just put this stuff this side. Now on this one, that's the Mosfet that I'm using. It's actually it's IRF 510. That's the IRF 510. And then if you hold it like this, you will see on the side there I've got my gate. So the gate is the first one here, and then the middle one is going to be my drain, and then the other one this side is going to be my source. So I'm just gonna put it like this. Just gonna put it like that. Then I'm gonna have it like this. So I'm gonna have my Mosfet like that, Mosfet transistor. So remember it's the N channel, so I've got my gate and the drain and the source. And then now I need to put the input. Now the input is gonna go where we've got the gate there, and then the gate is the first one. So I'll take this capacitor here, try to make it like this, and then I'll put it like that, and then put it on the other side there. So I'll connect it like this, and then connect it on the other side. Okay, so that's actually where I'm gonna have my input, and then I'll just take a wire here and then connect it over there. So that's where I'll give it my input signal. I'll connect it there, and then that's the gate. And therefore I'm gonna need let's start with the 200K. I need to take it from the VCC and then coming down to the gate. So I can actually take this one out here and then put it a little bit there just to have space. And then I'll take this resistor, take it from the VCC this side, so I'll connect it there, and then also take it to the gate on the other side. It's gonna be connected like that. So it'll be connected like this. And therefore I'm gonna need my 100K. So I'll take the 100K here from the gate again, and then it goes down to ground. So I'll just connect this one like this, to make it a little bit long on the other side, and to make it like this. So I'll take it from the gate here, just connect it there, one leg this side, and then I'll take it to the ground, which is actually on this side. It's gonna be connected like that. Right, so I'm done with my two resistors, R1 and R2, the basing resistors, and then now, or the gate resistors. So now I'm gonna go to my 470 ohm, and then it's connected to the drain. Remember the drain is the middle one, so it's taken from the VCC and then it goes to the drain. So what I'll do, I'll just use a wire, can just connect the wire here, just connect it in the middle there, and then pull it on the other side, and just connect it there, and then pull it maybe there. It's fine. So I know that this wire is going to be for my drain, and then I need to put the 470 from the VCC, so I can just take it here from the VCC up there, and therefore I'll connect it this side. Other side there, then that's more for my 417, then it goes to the drain, and therefore I'm gonna need a capacitor also, the 100 nanofarads, so I'll just connect it here, and it will be going to the output, so I'll actually connect it here and then put it on the other side here, and then I'll put a wire just to show that I'm going to be measuring my output here. So that's where I'll be measuring the output, the amplified signal here, and therefore now I need on the source, I need to connect my 150 ohm and then going down to ground. So what I'll do, let me just make this one a bit long. So what I'll do, I'll just connect this one here. Remember now on this leg, this side is where I get my source, so I'll put the source there and then take it down to ground on the other side there. So basically my circuit now is done with all the resistors connected. Let me just also make sure that all the wires, they are touching to the lines. Alright, and then that's how it's going to be. And then what I'll do, I'll just connect the wires for the input and also for the output, and then that's how the circuit is going to be. So yeah, so that's how it is. Right, so we're done doing our circuit, connecting it. So now we're gonna go to giving it some power, and then let's see how is it going to be. I've got my positive terminal here, then I'm gonna connect it. This is the positive from my power supply. It's gonna be the positive there, and therefore I need to connect it to the negative, and then the negative one, it will be this one. And I'll just connect it there straight from the power supply, and then that's it. And then now I need to take the input. If you can look at this one, that's the input from my signal generator. So I'll just take it to the input. Remember the side, that's where I'm getting my, that's the input, so I'll just connect it over here. Connect it there, right? And therefore take the other one to ground, to the negative side. I'll just go there on the negative, and then that's actually my input. And then now I need to measure. So now I'm going to measure the output on my oscilloscope. So I'll just take this probe, this oscilloscope probe, this one, and therefore the first thing that I need to measure, I need to check the input. Remember now we're saying that it's amplifying, so we need to check the input versus the output if we are going to have a gain. So I'll just measure it here. That's the input from my oscilloscope. Just measure it here. The input from the signal generator, measuring it using the oscilloscope. So meaning the yellow one is going to be the input, and then I'm going to take the second one, which is the blue one, measuring it from the output here. So I'll just put it there, and that's going to be my output, and then I'll just take it to ground this side. Right, so everything is being measured up. So what I'm going to do, just need to put the output there. I'm taking it to 12 volts or 12.1 is fine, and therefore I'm going to have to give it the wave there, and then everything is done. If you can look at the oscilloscope there, I've got 1 volt per division for both channels, and then the yellow one is actually the input one, and then the blue one is going to be the output. So if you can see there, the output is 180 degrees out of phase, but however if you can look at the peak or the amplitude, it is bigger than the input. So basically it's amplifying, it's taking the input and then it's giving it amplification, so there is a gain. So that's actually how you get to build your MOSFET as an amplifier. So thank you.